So good evening to you. So it is evening now in Arizona, right?
Yes, good morning to all of you.
Yeah, thank you very much. All right. So here we have about 220 new master students, and then around there are 10 new doctoral students. So we have in total 30 doctoral students because we just started doctoral students last semester. So also a big interest from people to join our program. And we are in the department called technology management. So as I mentioned earlier, people are doing business analytics, supply chain management, industrial management, IT management, and then project management. All I think are within the area that you are familiar with. And we are very much lucky actually to have you here this morning. And your presentation is really very interesting. So we are looking forward technology development in the future, and we actually want to train people to get closer to the requirement of what future people need in their capabilities and competencies. So without further delay, I would like to hand this over to you. Probably you could introduce a little bit about yourself at the beginning, but I think I already distributed your CV to these people, so they have already read. But it is good actually if you start a little bit with your introduction. So Mani, it is your time now.
Thank you, Professor Nami. And I'm going to go share my screen now. So
Yes.
let me go ahead and do that. Make it smaller. So I hope all of you can see my screen.
Yes.
Okay, great. And
That's
is my
perfect.
voice coming through okay?
Yes. It's
Okay,
perfect.
great. Okay, good morning. So Manny Janakiram, I've been at Intel for the last 21 years, and my journey has been through. When I look back at my education, I was born and brought up in India, and I did my engineering, mechanical engineering, and I actually worked developing robotic tools and pick and place, designing them. And then that interest brought me over to USA to do my master's and PhD. And I came to Arizona State and ended up doing my master's and PhD in industrial and systems engineering. And then I worked for Allied Signal Aerospace, which is now Honeywell, and then worked for an automotive industry, and then Motorola, and since been then mostly Intel. So I have a kind of a background of engineering, aerospace, automotive, and high-tech semiconductor. And throughout my journey, when I look at my PhD and when I look at my master's, engineering foundation, primarily understanding and solving problems in a methodical fashion was something that is helping me even today with the kind of work that I'm doing. And another thing that is common across my entire career was the data systems and analytics. And I think as engineers and as students, you are going to, whether it is project management, whether it is supply chain, whether it is industrial engineering or mechanical engineering, you are going to deal with data. You are going to deal with systems, and you have to really understand how and what you need to do with it to uncover like the truth, hidden truths behind the data. And that has been my journey. And the concept of digitization with artificial intelligence and advanced analytics, it does not matter what field you are in, whether you are in communication, whether you are in medicine, whether you are in engineering. You have to uncover the truth from the data, and you have to know how to do it. And it's not just enough how you do it, it is also required that you sell your ideas and your inferences to the right people so that the right decisions can be made. So those are all the kind of things that I have been experienced in my career, long career. And also not only like an Intel, like employee as a senior director, but also I'm an adjunct professor at Arizona State University, and I'm also a guest lecturer at MIT. So based on that, like what I want to share with you today is primarily how the industry is shaping. What are the things you can take away? And I want to just start with Intel. When you look at Intel, like, even if you go 15 years ago, or like let's say 2000 years ago, Intel was considered more like a PC company. Basically making chips for our laptops, our computers, right? And we evolved. This is a good example of how the industry is evolving and why we all need to evolve as well. If you look at Intel over the last 15, 20 years, we have gone from a PC company to PC and data center in the middle of 2005 to now. We're really what we call as a compute company, meaning we are really looking at unleashing the potential of data. And why is Intel transforming? Intel is transforming because that's our customers, that's what the market wants. And exponential growth in data is kind of creating various opportunities, whether it is in communication, whether it is in storage, whether it is in memory, whether it is in analytics. And when you start putting this together, honestly, the magic is happening. And when I just put this picture on the right-hand side to show that how the data is changing over a period of time. When you look at, the 1990s, the type of data that we were dealing with was very structured data, like primarily numerical data that is 0 or 1 that needed a compute capability only. And as we moved into the web and the video, like a video and communication world, the data is not just 0, 1, it's audio, it's video, it's different cameras, images. So the unstructured and different type of data is happening. And now adding to it the IoT, Internet of Things, it is making everything speak to everything else and connecting everything to everything else. So as you can see, the data is exploding. Number one, we're talking about petabytes of data and and beyond. And how do we deal with that? How do we manage that? If you don't, we're not going to get the entire truth. We're not going to get the entire value. So that is why we are really looking at how do we, manage this exponential growth of data so that we'll be able to connect every person on Earth. And Intel is primarily focused around powering the growth. And I play a part of data connectivity, and I'm starting out with the supply chain. So that's why I'm kind of saying that supply chain is also critical when we do these kind of things. And a couple of things that come to my mind, primarily when you look at, why, these things are happening. Why? What is the reason behind this kind of a smart digital growth? And the reason is, when you look at the data, the memory, the reasoning, and compute, memory is really cheap. The compute is really cheap. It is available. The size and everything that can you can think of a terabyte sticks in your pocket. The first instance of computer had 40 meg or 8 meg memory. So you can imagine how it has grown leaps and bounds. And when we look at what the industry is saying, for example, like IDC, basically it is one of more like a Gartner, automation technology will expand at like compound annual growth of 16.8. In fact, it may be even growing further out because that is slightly old information. And also, why is this digital, intelligent digital information transformation is so disruptive? When we talk about changes, the change can be incremental changes, meaning, I see a problem, I fix it, and then it's better now. Or when you look at the automotive industries over a period of time, improving mileage, improving, stability, improving safety, it's been incremental. All of a sudden, like an electric vehicle comes and it disrupts the whole world, right? For example. And then, it's almost when we look at all these vehicles, autonomous vehicles and things like that, it is nothing but a compute on wheels, right? It is so disruptive. Why is it disruptive? Because, when we start looking at this, digital business models and technologies, they improve the performance very appreciably. And in order to do that, we as a whole need to challenge assumptions that delivered past success. If we are comfortable with what we are doing, and then if you're comfortable with the incremental changes, we may not be able to get this disruptive kind of changes. And then if you know that this is what is working for me, and you should be able to even stress test further to see what more I can do. And in fact, the Gartner 2020 survey indicated that 82% of the CEOs have initiatives to make their business more digital. So for the students out there who are graduating, the question is, do I know what digital business is? Am I using digital solutions, or am I learning about systems and tools and cloud-based solutions, analytics, and AI, so that I can be part of this revolution, right? And the next question is, I wanted to kind of, like, I don't know how many are familiar with the Industry 4.0, but I just want to bring that here as a context for us to understand exactly what is going on. We are in the fourth revolution of the, Industry 4.0. That's why it is Industry 4.0. And when you look at it, like it goes back all the way to 1760s, 1840s. That is when the first, like industry, like Industry 1.0, you could call it, mechanization, water power, steam power happened. And the second one was more like mass production, assembly line, electricity. Like that was more that space. And then came the, like a computer and the information revolution. And we are going through, like when we had the World Wide Web, when we had, like a data and webs, like all the, .com revolution was more like a consumer revolution. And now what we are going through, 2020 plus, is intelligence revolution. This is where AI fits in. And, it's actually, a lot of people coin this as cyber physical systems because of the artificial intelligence, robotics, virtual reality, and like deep learning, all kind of coming together. And when you start to look at what are the different technologies that is being shaped for us to leverage going forward, what are the technologies that I should be learning if I'm a student? What are the technologies I should be leveraging if I am a professional? And if I'm an executive, what are the technologies I should know? For example, these are listed here, right? I mean, Internet of Things, augmented reality. In fact, now it is called mixed reality because we have augmented reality, virtual reality, and mixed reality, additive manufacturing or 3D printing, simulation and from various big data, unstructured data, and the cloud computing has taken. And now we are in the autonomous systems world, whether it is robotics, whether it is, like a simple, vacuum cleaner like a Roomba that automatically, is scheduled to go clean the house, or Japanese robotics, primarily with almost a human touch, or autonomous vehicles. The question for us here is to pause and ask is, like when you are working on, like as a professional, as a, upcoming, like in a professional, right? What processes should we transform? Where to invest, and what advanced technologies can best serve? Just because the technology is out there, it does not mean you have to go embrace it. A good example, I would say, is blockchain. Blockchain really matures into a potent potential capability that we can leverage. And there are very good instances of blockchain solutions. What I'm saying is for common applications, it still has, like paths to go. And one thing that I want to really stress is not keeping up with it, someone else will. That means we become archaic. So how do we ensure that we individually are keeping up with technology? Industry and academia as a whole is embracing technology, and the curriculum is like geared to teach this kind of technology, or this upcoming revolutionary things, and the business and industry are able to leverage them as well. And there, like people talk about artificial and years ago, like what are we talking about? It is not that it is something that was invented today. It has been there, but it has matured to the point where it is primarily becoming, like I wouldn't say it is singular in the sense it is taking over, but it has matured to the point that it can, coexist with us. It can actually help us and take us from a decision support to decision enabling to decision making. And some of the examples I'm sorry, there's a question?
No, I think there is no question. You can go on.
Okay. So what I did here was just to kind of put together different, AI instances. I think, like autonomous driving, self-driving taxis, and in fact, in Dubai, primarily the drone, self-driving drone is being, they're testing it out. And then Amazon actually is now starting to deliver, like drone delivery. And in some of the countries, I understand it's already happening. Medical supplies in Africa and other places, delivery of like blood and other medical critical components are transported via drone from a point delivery. So a lot of these things are happening point to point. And I was also mentioning about the data explosion, right? If you look at the smart factory, it is producing around 1 petabytes of data every day. If you don't know how to deal with it, the data is going to go as a waste, for example. So these are some of the things I wanted to put together in our discussion. And I was recently reading a National Security Commission on Artificial Intelligence. This is the latest information, where the future is going and how the artificial intelligence, the AI, is the center of this constellation of emerging technologies. This is where, like when you look at microelectronics, that's the industry I belong to, the semiconductor high-tech industry. Robotics, for example, 5G, advanced manufacturing, energy, biotech, quantum, every one of them. In fact, it's interesting that they have not called out commercial, because commercial in terms of consumer selection and the retail business is also very AI centric. So primarily, like AI is at the center of all these things, and then embracing, enabling, and understanding is much critical for us. And I was also looking at it from overall, where what are the critical things that like it's going to improve. This is based on a Gartner survey, and they actually interviewed around 1,000 plus supply chain professionals, and from a overall supply chain perspective, they were looking at where and how the AI is going to be disruptive. And what are the important digital technologies that we, as a, like from my perspective, we need to look at? The number one thing that came out of here, as you can see, is big data analytics. And along the same lines, Internet of Things, robotic process automation, cloud computing, 3D printing. I probably would stop there, but I think this is what the industry executives are indicating, and this is where they are starting to spend the money, and this is where they're also hiring people. So I'm not saying that our traditional roles are going to go, but in terms of like breaking the glass ceiling and going to the next level, these are some of the areas that would provide, like would actually propel your career. I started out as a mechanical engineer, but I am now an AI engineer. So I can tell you that the journey, took a long time. But if I knew what I know now when I was studying, I probably would have done something differently, right? So those are the kind of things you would look at. And also, why is that, like at Intel, I'm actually enforcing and I'm actually enabling and implementing some of these AI solutions in supply chain, in manufacturing, and also in some of our, other areas. And the reason is we're looking at, this is a disruptive technology. I don't know how many of you have heard about the Disruptive Innovation by Clayton Christensen. And I think that's a very good book to read, in the sense that it talks about how the disruption in the industry happens. And so primarily the customers create requirements that sometimes, like puts you in a spot to think about, can I do something differently? And if you have a customer that is most demanding, that is where the innovation starts to happen. And so you can think of it as, I can do incremental, but there comes a disruption. Some of the examples would be, like you must be familiar with the blockbuster video and things of that nature in the past. All of a sudden, Netflix comes in and the whole model goes away, and you can see anything, and you can download everything. You can watch the movies, you can rent them via, the media like that. And then another disruption is primarily shared economy, where, the taxi services are being fully, put to question by shared ride like Uber and Ola and others, right? So the disruption is where it kind of takes the industry by jolt. And from an AI perspective, I'm looking at what are all the different things we can do. And as you can see, it basically provides you all the best metrics, whether it is improving velocity, improving agility, meaning I'm able to flux and move faster and adjust my business according to the needs of the industry or the customer. Then the productivity hours goes up, and increases resilience, meaning particularly we're all living in the COVID world, and we have gone through such a turn and twist and turbulence last year. Still, we are kind of recovering from it. And if you have a ability to withstand all these changes, that's where the resiliency comes from. And it has the ability to absorb complexity and reduce it. And of course, reducing cost from all these things is how I'm looking at it. And with that, actually, a couple of years ago, I started calling out autonomous digital supply chain as the vision for our Intel supply chain. And the executives brought into it. And the whole idea is very simple, right? When you look at where we are going, well, and I was trying to explain, manual process to automated process to autonomous process. The question was, you must be crazy. How can a supply chain be autonomous? Like it has to have, inputs, it has to have humans, it has to have humans making decisions, it has to have enterprise systems and data that all works together. Granted, that's true. But the example I started putting together is all of your students probably may not even know, or may not even see the paper maps that I ended, used to 20 years ago when I would go to visit a customer, visit another factory. I would fly into a new city, and I would rent a car, and the car with the key, they will give me a map, a paper map. And I have to really decide how I'm going to navigate my path from airport to the wherever I'm going. Of course, I used to get lost and things like that, but that's the status of where we were. And today, you just pull up your like iPhone or a smartphone, and then whether it is Siri or Google, you just primarily speak to it, and I want to go there, and then voila, you have the direction happening, right? So that is very automated. And not too far away, but few years from now, you don't even get into the driver's side of the car. You may be sitting in the back, and the vehicle would know you, your destination, and your schedule, and before you know it, it'll take you there. So that is how I've kind of looked at it, and I said, what is that we need to do to make our manufacturing, our supply chain autonomous? I know that this is a long order, but then we started looking at how do we go about doing that? And that's actually the process that I'm adopting to look at our procurement cycle, our manufacturing, like with the sensors and IoT and automation, our automated warehouses, and our distribution systems, our planning systems. And what we came across is some of the foundational challenges. You know what? Our people are not ready. We don't have the right talent for doing it. Culturally, we are not ready. And I'm worried about, the AI taking away my job, some of those things, right? The other part is the data and systems are not connected. They're not designed for the AI world. And then, of course, like the operational systems are not, fully functional or connected, the business processes. And only when you have all these things done, that's when we can go into this advanced AI. And that's the journey we are taking right now. And Then I started to look at mapping our supply chain requirements from an info perspective. When we looked at it, like how do we get to the cyber physical system? And I might call it as autonomous digital supply chain, but what exactly are the things that we need, the disruptive technologies? And this again was another survey. And when we looked at it, artificial intelligence was on top of the list. And then, of course, artificial intelligence does not happen if you don't have the right big data, if you don't have the machine learning, if you don't have the sensors and actuators to pull the right data, and if you don't have the robotics that would enable things to happen, right? So this is where we started thinking about how do we integrate this? How do we get to where we want to go? And like another way of looking at it is, what are the different exciting operating technologies that we need to embrace? And so I kind of mentioned some of this, but I just wanted to put it as, what are the things that are ready to go now? What are the things that are emerging? And in this particular case, we started to look at, autonomous things, IoTs, advanced analytics, artificial intelligence, and so some of the things that we are starting to look at. And then based on that, we started, we created an innovation lab where we actually started to work with universities. In fact, I fund several universities in US and work with various graduate students and professors on, like with the innovation lab. We jointly work on some of these projects to really look at how do we get this kind of research and innovation going. And internally, we're also looking at what are the opportunities to implement them. For example, the supply network modeling, the digital twin is something that we are developing, so that the whole idea of a digital twin is taking, for example, some of the equipments we run in our semiconductor process. For example, if you're building a fabrication facility, it can be anywhere upwards of $4 to $5 billion to build it. And some of the equipment, the most critical equipment is the lithography equipment. That is, one equipment can cost anywhere between 100 to $175 million. And we have like 30, 40, like a lot of tools of that or the, spread over the geo. And how, like if I'm not getting value out of my asset, that means I'm wasting my asset. How do I get best value out of asset? By knowing, like how the equipment performs. How do I know the equipment performs well? By modeling, by monitoring, by actually putting it to use. And that's where we are building, digital twin of that equipment so that we can test different things. There's nothing new when you look at some of the companies like GE has built their digital twin of their engine, aircraft engine, so that they can actually monitor the performance. So when does, like the other question that comes up is, I don't understand the difference between, like modeling or a simulation and a digital twin. Mostly the modeling and simulation happens when you are looking at some strategic scenarios. So what if I do this? What if I do that? If I change this now, what output is going to be? And the reason, how you go from that, like a scenario planning and then kind of a strategic modeling to digital twin is when you take the same model, digital, like impression of your equipment or your process, and then you connect the actual data and system that starts to feed that model. Now, what you're doing is you're actually running your simulation, and then you're taking the data that's coming in, and then you are doing comparing and contrasting, and now you're starting to make decisions that will impact the real world. So that is where the reality sets in. So we are starting to get there, and I know we have ways to go there. And the other question that, like several other things that I've outlined here, for example, is autonomous planning. Once again, when you look at our factories, for example, in semiconductor, we have the front end is called the fabrication facility, the back end is assembly. And our assembly facilities are all over the world, mostly in Asia. And our fab, so US, like Israel, Ireland, China, assembly facility is in Malaysia, is in Vietnam, in China, in USA. And then we have a lot of testing and modular in all over the world, including like Japan, India, and we have 10,000 suppliers and making various products for us all over the world. So primarily, how do we understand what is going on? How do we plan things to that go one place to the other? So that's where we have a huge autonomous planning system. It is a combination of an operation research solver combined with machine learning to really understand what do I need to make, when do I need to make it, and how much I need to make it, where, which factory I need to make it, and then what do I learn from it so that I can quickly, nimbly run it together, things like that. And then we also are applying the power of robotic process automation, machine learning, and natural language processing and AI in automating our contracts and digitizing them, so that we almost, like we write thousands of contracts, and if there is an audit function, it was taking a lot of time for us to really go understand, do we have the right contract in place? If there is a breach or violation, where do we go? Today, it's completely checked, and then the dashboard that has got intelligence will flag you if there is a problem with it. And one of the things that most of the companies in the world struggle is having visibility of what is going on, whether it is visibility across the factory network, visibility across supply chain, or the customer, like how the market channels are working. So what we have developed is, in addition to the control towers, we have developed AI-enabled predictive visibility, meaning by taking the data, big data, and cloud solutions, we are combining all the data to show where my product is at any given time, what is happening with my factory, what are the different issues that may come up. On top of that, we are also modeling to look at what if this happens. And this kind of capability helped us a lot when, like last year, when we were looking at COVID, from a customer perspective, from a employee perspective, and also stakeholder perspective and market perspective, we were able to look at where and what changes we can do, what are the scenarios we can, how does it look. So that helped us. And then, of course, we need to have our eyes and our ears across the globe. A lot of things can happen, and we primarily Intel being 100,000 company, it is important that we are, our suppliers and our employees and our company, we're all compliant to various things. Very critical thing. And then we are able to develop using the power of AI and cognitive computing. We, like using web and interfaces and Twitter feed, we are able to pull all that information out of, from all over the sources to really understand if there is supplier financially, like any challenges, is there a natural disaster that we need to respond to? Or if there is a child labor that is happening that we need to go avoid, things like that is something that we have developed. And we, like one of the challenges we're facing right now is we have a lot of these solutions. Now, in the name of autonomous digital supply chain, we're trying to create an integrated view of things so that we can start to leverage these things. And so when we do this, like for example, if I'm able to connect all the dots, if I'm using various aspects of my supply chain, my cloud computing, my automation, AI, and IoT, this is an example of a supply chain that leverages that. For example, right here is, like look at all the connectivities. We have end-to-end visibility that is basically telling you what's happening with your product, what's happening with your supplier, what's happening with your customer, and is the product being shipped, is the incoming material coming on time, things like that. And then you're also harnessing the social media and environmental data to really understand, for example, what would be your footprint and things of that nature. And then you're doing shipment tracking, you are monitoring your factories, and you're monitoring your warehouses, or like you're connecting and communicating with the customers. So all of them are happening in a seamless fashion, so that when this information is connected intelligently, and then and we can sense and respond, or for that matter, we can anticipate what could happen and respond to it. That is where the revolution of these things coming together is what we're looking at. And I know I'm kind of going through all this information probably really, really fast, but there is, like one particular slide can take maybe, even 30 minutes if you still want to start digging into how it works, what are the different challenges. It's not just the technology challenge, it is also cultural challenge. It is also strategy challenge, because if you're not ready for this change, if you don't plan this kind of a change in your DNA, you're not going to be able to really get value out of it. And one thing you have noticed is, as part of the strategy, it is very, very critical to have the right kind of talent, and not only incoming talent, but also the talent that we have that we need to upskill, whether it is a data analytics, whether it is subject matter expertise, whether it is, even for that matter, like we actually go and hire good project managers with sometimes PMP certification so that they know what they're doing, because most of the work we do in the development activities is project. If they don't know the metrics to measure, if they don't know what the risks are, what impact the risk would bring, and then if I don't know how to measure, like scope creep or schedule, like for example, they need to know how to manage scope, schedule, and budget. If they cannot do that, that becomes harder. So hiring right, training our folks right, and then like that's why we look at attract, hire, integrate, develop, and progress. It is a very critical activity that we take very seriously. And talent is something that right from our CEO is a big part of Intel success. And so this is my last slide. And then the question for all of you is, you might be wondering, this presentation is geared more towards industry professional, you might think, but honestly, all the message that I'm sharing is applicable across the board, right? Because if you have to plan and prepare for the future that you may or may not know quite well. But we're all intelligent, always think what could happen. And if you look back, the history tells you how things have changed. So understanding, what matters, right? How do I make changes? What are the changes I need to make, and for whom? So that is the mindset part of it. For us, for industry, it's customer focused, possibility thinking, right? Meaning if the customer is saying, I need to do this product in a different fashion, then the easy answer for us is, no, this is the product we have, you can have it. Or we would say, well, this is what we want, we'll go look into it. And we will go work on it. That's a possibility thinking. And then leadership, right? Leadership matters. Primarily, like the founders of Intel is what I have listed there. In fact, to the extreme right is Gordon Moore. The semiconductor industry for the last, 70 years, right? I would say, like latest, because the Gordon Moore was 97, I believe. In that time frame is when it was, like he created like a simple graph on a napkin piece of paper showing that primarily the transistor technology is going to double every 18 months, while the price of transistor is going to be half, while the size will also be half. So the industry has taken that simple concept, and the semiconductor industry has grown leaps and bounds. And today, if you're able to hold a laptop or like a tablet or a phone in your hand, because all these form features and everything happened because of that, like a primarily thought process of how can we make this smaller, faster, cheaper, and overall better. And so that kind of a visible management commitment and leadership is critical. And then one thing that I've noticed is learning never stops. If you think that you know what to do and how to solve problems, look again, because the situation around you is changing. Even today, I am learning every day in terms of what are the next technology that I need to embrace. What are the things that I can do better from yesterday? So continuous learning not only like makes you to improve your ability to respond and have new capability, but it also builds your muscle memory, right? Because if you do the same thing over and over again, the next time you do it, you don't have to think about it. So that's very important. So primarily learning today, implement tomorrow, and that way you prevent future threats is how I'm going to be looking at the whole activity. And with that, I am going to stop, and I can take questions.
All right, that was a great presentation, Dr. Janakiram. So we got a lot of insight from what you have been presenting to us, and there are a lot of questions in the chat already. So students are very enthusiastic about this. And the problem now is with me, I have to pick some of these. Probably don't have enough time to address all of the questions, but I have seen, maybe half of them. Some of the questions are actually related to, I think there is one a couple of questions that ask you why Intel needs to transform from initially it was a computing industry to more toward data and artificial intelligence. So that's probably one, if you would like to address that one first.
I think the reason is the industry around us is changing, and data is becoming critical. And the PC as a whole is not going to address it, because when you look at the adaptation of computing, PC is actually, like kind of around 1/3 or less. So that means how the data is converted, whether it is IoT, whether it is cloud, is where we needed to change. Sorry, can you hear me okay?
Yes, yes.
Okay.
Yeah. Yeah, right. I think there is one follow-up question from other student who is a little bit related to that one, about whether or not COVID-19 actually able to accelerate transformation in your company toward artificial intelligence in future supply chain.
It actually made us aware that we need to have solutions faster than what we were planning on. And because the things that we have taken I'll give you an example. We were able to accelerate the ability to use AR and VR in the factories much better because of the COVID. Primarily, like with people working from home, with supply not able to travel to the supplier site, we started leveraging cloud solutions. Is implemented AR and VR solutions much faster. So in that aspect, yes, it did.
All right. So thank you. That's clear. I like your answer to that one. Okay, I will mention two more, and I will give opportunity to students to directly ask to Dr. Janakiram. So there is also a question about the investment. Do you think the investment that needed to embrace the technology will get cheaper in the future, probably, because maybe currently there are companies that come to an issue about the capital that needed to invest to this kind of technology?
It has already gotten cheaper, because when you look at the companies that are coming from like various, you can be sitting in a corner of a world, you can come up with an idea, and you can actually create a product and a solution. You don't need to have for example, I've heard about some of the inventors who developed a new conversational technology, and then they go to like a marketplace where someone is willing to design it for them. It's a shared economy. Someone is able to fabricate it for them, and companies like Amazon can actually take over the entire supply network for them. So there are so many instances. There is one-person companies making, like developing this kind of solutions and breaking the market in a way. So the technology and the things that we know that I have to have this infrastructure, I have to have this capability, has changed significantly now. So.
Right. So it doesn't mean that one company need to invest fully, because there is an increasing that companies actually sharing resources among others.
Exactly. I think the IP, intellectual property, is much more critical. And whoever is coming up with the intellectual property, there are a lot of angel investors and everyone wanting to follow that. So.
Right. Okay. So now I'm giving opportunity. There are a few students actually. Okay, I think Mr. Agung, you I think
thank you, Prof.
would like to ask directly, right?
Yes.
Yes.
Thank you, Pak Prof.
Yeah.
Good evening, Dr. Mani.
Hello. Good morning.
Yeah. Thank you. It is true that it's a great lecture. I'm so overwhelmed with the insight that you have given us this morning. I would like to thank you for that. Okay, it is interesting to hear that, in fact, COVID is even accelerating all the digital transformation at your organization. But I'm going to ask you, I'm going to touch base on the very basic fundamental of live dialogues over any supply chains and logistic problems. We know that this COVID things, I mean, this pandemic outbreak has turned our life up and down. I mean, causing a great construction in economic, and then of course giving a turbulence in our life situation. I'm going to say that there are a lot of uncertainty. I mean, during this at the time of uncertainty, when dealing with this uncertainty, I mean, what if has time has come for you to choose which one come to your which one come first to your prioritize, whether the reliability of your logistic system or the efficiency. I mean, this always between these two, right? I mean, are you going to give up your reliability to get perhaps efficiency so that you can survive, or the other way around? You're going to give up your efficiencies to get your reliability. I mean, to support your life. I think that's my basic question. Thank you, Dr. Manny.
Great question. When you are stressed for life, when you have to supply, like critical, like medical devices or equipment, I think the efficiency and operations will be secondary. It is always critical. When you look at the Maslow's triangle, right? The need outpaces the want. If I have to have my supply, if the demand is really high, I'm willing to pay anything for that. And the operational efficiency and everything will have to happen. But in this particular case, I would prioritize logistics, because if I'm saving lives, and that means I'm going to, like not only be a corporate citizen, it is my, like as a human being, I have to do this. And then if I do this right, then everything else we can catch up later, is how I would look at it.
Thank you.
Okay.
Thank you, Thank you, Professor.
Okay, thank you, Pak Agung. Okay, that's a great conversation, I think. There is another hand raised from Ibu Umitri. Are you going to ask it directly? Silakan, Bu.
Okay, good morning, sir.
Good morning.
I take your course in AGX platform more than once. I would like to ask and get your insight. If I'm a person in an international e-commerce and I don't use 3PL or other third party, and I want to arrange new transportation, I want to change the routing line from the lot of I have. What is the most important things I should consider? And I want to develop the AI with my team. In the condition I'm a beginner in coding language who only know this, the basic SQL query. Can you suggest me what is the language should I learn first, which easily to understand? Is it Python or others? Thank you.
I think definitely that's a very good question. Also, primarily it is not necessarily for transportation. It can be for planning. It can be for procurement. And depending on the size and scale of how you're implementing it, for us, we use Python, we use R, we use, for example, we're also a big Microsoft house. And if you're developing solutions, I also look at some of the package solution. Like, for example, if you're doing transportation, if your goal is, I want to reduce my landed cost, I want to optimize my routes, you may be looking at, you can start with the Python and write a code connecting, warehouses, transportation network and everything. Or you could look at softwares that are available, either open source or available, like I would say LambdaSoft or, any logic. We have some of this logic built in. So you will be able to get to the solution faster. But if you're not willing to, if you want to build your own, you could actually start with Python.
Thanks for suggestion.
Okay, thank you, Bu Umitri. Okay, another questions another raised hand from Pak Iman Prakoso. Okay, I would like to invite you to ask your question directly. Yeah.
Okay, thank you, Prof. Man and Mr. Janikram for this opportunity. Mr. Janikram, you shared to us before about the growth rate and innovation that Intel have for 20 years back. Also in Intel improvement in this disruptive era and else. Could you share to us your point of view or about which direction should the company make the development or improvement to accommodating the market versus the improvement or development for creating the market? This is maybe you can share your point of view for general for all kind of businesses or manufacturer. Thank you.
That's another question. I think the way we look at it is customer comes first. Our obsession with customer requirements is critical for us. So knowing what the customer wants and knowing what the customer is not happy with our products or solutions is step number one. Step number two is what the market is offering, where the market is, where we are, so that we can come up with the solution that the market can adopt. And then we have to really take a hard look at our capacity and our capability. Just because the customer is asking for a rocket, does it fit within my strategy and my solutions, right? So that kind of a fit of what the customer wants, what's our capability, we can leverage voice of the customer, voice of the process, and what is the best path to go there, and how do we, how are we profitable, as well as serving the, like community today and tomorrow is one of the things we look at it. From your perspective, the best place to start would be, like your strengths and your, areas of development or weakness, and then mapping it to what your key customer or stakeholders want, and then looking at where the market is interested. You may have the best golden knife that you're capable of making, but if no one wants it, you may want to really look at what is that market wants. So that would be my recommendation.
So you mean that the first one we should be look at the customer needs first. Then if our company can, it can be meet in the middle, where's the market wants, customer wants, and our capability. Is that correct?
Exactly.
Okay, thank you, Mr. Janikram and Prof.
That is another great insight. So the customer always come first, and then we match capabilities with what we have inside, right? Okay, another question from Pak Pratama. You can ask directly. Right. Okay. Can you
hear me, Pak?
Yes.
Yeah. Good evening, Mani. Thank you very much for your insight. My name is Pratama, but people call me Raja. In Hindi, my name is Naresh.
Oh, I see. Good morning, Naresh.
Yeah. Well, actually, I'm really new in what is AI or technology, which is IoT or some kind of thing, because my background is in manufacturing industry. So my question is, there any project in Intel so we can collaborate to Indonesia to help industries among in Indonesia, Mr. Mani. So at least maybe we can collaborate with ITS. Maybe small project that I don't know, but in my industry, I'm working in energy industry, Mani. So IoT AI is very not common in our industry. So maybe not energy industry, but maybe in manufacturing or other industry, actually in Indonesia. So maybe we can collaborate, because actually I'm a businessman. So I just want to, is there any, step further to, help improving AI in Indonesia. So we can embrace this technology in Indonesia to implement it. Thank you, Mani.
Thank you. I don't think we have a manufacturing or a supply chain base in Indonesia. We definitely have customer marketing base. And if I understand correctly, the kind of research that is happening is we are spread a lot over, like in Asia, primarily in China, in India, in Vietnam, in Singapore, Malaysia, Hong Kong. And but Indonesia, I need to go check on that one. Also, not sure how the process works for that, but Professor Neumann, maybe like we can be in touch with that to see exactly what the options are. Yeah. But as far as I know right now, I don't think we have manufacturing kind of a research in Indonesia.
Mm-hmm. Yeah. Right.
Manufacture and then also cement industry that we can help this manufacturer to improve the business. Like I saw your presentation that we can decrease the OPEX and also the CAPEX. Yeah. Right. So that's I'm very interesting. So maybe we can do further for this many.
Absolutely, we can look at options. Yeah. Right now, nothing is coming to my mind in terms of our investment or our projects, but I can check on that.
We can also collaborate, Pak Nyoman, with the industry, Pak. So we can help industry for this, Pak Nyoman.
Sure.
Okay, that
is a great idea. I think we
can. Yeah, Pak. With ITS also, Pak.
Yeah, follow that up.
Yeah,
so,
yeah.
Because our student consists of many people like you who work in industry. You know your need, and also can connect with the technology developers like Intel or other companies in the future. I think that's great. Okay, thank you, Pak Pratama. Okay,
thank you.
Another one, I would like to invite Pak Rai Sugara, who is also raising his hand.
Thank you, Professor Nyoman, for the opportunity given to me. Morning, Mr. Janakiram.
Good morning.
Glad to see you here. I have a fundamental question, actually. Of all the AI's advantages or the technological advantages that you've been described earlier, there are also many weaknesses that happen at the same time with that many advantages. One of that weakness that I think it is so full for the human civilization. I think that is my hyperbolic words. As we saw in, for an example, as we saw in Changi Airport at Terminal 4, Terminal 4 doesn't use human power at all. There are so many innovation of technologies that happen over there. This will certainly increases the unemployment rates because it is important for me. I also work for government airport operators in Indonesia. Of your point of view, Mr. Janakiram, how does Intel as a technology company respond to these issues? Is there any special studies conducted far days earlier?
I think that's a great question because there are trade-offs, right? Because the technology, the challenge that we run into is AI going to take my job, right? And in some cases, the answer is yes, because I cannot lie to you. Because if the technology, like for example, if someone is working on all the Excel solutions together, and all of a sudden you are looking at, you know what, it is prone to delay, it is prone to error. But if I create a robotic process automation that streamlines the business process, that collects and pulls all the data, does the analysis, and shows you what you need to be doing, that means the person who is doing the Excel patch up, if he or she wants to continue doing that, that may not be the job that is available. But the opportunity how we create is we want to upskill our people. Like, for example, the same person can be trained to develop the RPA solution, robotic process automation solution, versus writing and doing Excel. So that is how we look at how do we upskill our technology, our people, And the same thing happens in the factories. The factory is already automated. And some of the material handling, for example, when you're handling wafer, it is so critical because one wafer can have millions of transistors with hundreds of millions of value, depending on how it is. And we cannot have it exposed to the atmosphere. So that means it's a fully automated factory, how it is moving. But in the remote operate, the human intelligence to really decide what is happening, how we want to do this. And when we have the product in the assembly, we have people moving it and houses. So we are trying to balance and optimize those kind of things. So it's a difficult question, but the way we look at it is upskilling the people and then maintaining the balance.
Yes, so I think the human capabilities will have to increase in the technology aspects, maybe from the factory, maybe from the software engineering and so on, to support the AI technology that will be applicable for the airport industry earlier.
Exactly. I think it may be best to really take a look at where from in your perspective, you're looking about like within the airport, managing the terminal, what are all the different things that are happening today, how it is done today, and then state of the art, you mentioned automation, right? How it is done, what is the value? End of the day, you're looking at what is the value to the human, right? And how do you measure that? And then looking at how can we bring the people along to improve that value? So that kind of a strategic path would be helpful.
Of course. Thank you for the answer, Mr. Janakiram. That's so enlightened me. Thank you, Professor Nyoman.
You're welcome.
Okay, right. I think that's also a very interesting issue. And there are a couple of questions related to that as well. Probably, Mani, you would like to address a little bit more about what kind of skill set that probably we need to develop to anticipate future working environment where we need to make a different balance between human brain and machine. Like, for example, I think you have a background in industrial engineering, like myself as well. So when we are developing curriculum in industrial engineering, we are always thinking about how to design our curriculum to meet the future demand in industry with a very fast-moving technology development. Do you think we need to strengthen the basic, or students need to grasp more of the wave that are moving from time to time? What do you think?
I think I've seen like different approaches. In fact, as part of some of the curriculum development here at ASU and also with MIT, what I've noticed is you have to keep a foundation always strong.
Yeah.
So without the foundation, everything else becomes weaker, right? Because I have seen a lot of people who come and have a good data science background, but if they don't know how to solve the problem, if they don't know how to address, the critical things, it becomes, or if you don't have the subject matter expertise, it becomes very difficult. For example, a supply chain planner, if the planner does not know how to plan, what is like long range planning, and how they do different calculations, forecasting, and everything, they can, even if they are good data scientists, they cannot get the basics. So I was kind of I created a diamond model when I was sharing this with some of the students. The model that I have is like it's a 4 corners of the diamond, right? One corner is you've got to be really good at your subject, like whether you are a mechanical engineer, you are a designer, you are a supply chain, you are a manufacturing person, know everything about it. The second part of the second corner is like it's kind of a soft skills. You may be the best engineer, but if you cannot communicate, if you cannot get your point across, it's not going to help. And so the communication skills, the project management skills, the teamwork skills, leadership skills, they matter. And the course and curriculum should actually address those things. And the third one is the data and analytics. That is where the data science is coming along, because if you don't know what you're, if data is presented to you, and if you don't know what it is telling you, and if you're not able to take that data, convert that into information or insight, it's not going to go anywhere, right? You may be designing the best product, but if you don't know how to analyze data coming out of it, you'll be looking at someone else. And so the curriculum around data science, whether it is statistical analysis, whether it is linear programming, modeling, simulation, like that is also critical. And the fourth one is software skills, in the sense that I have struggled in my career because I did not, like initially I didn't know to write SQL coding. So I have to learn SQL. And once I learned SQL, it opened up a lot of avenues for me. I know how to analyze data if somebody gives it to me, but I didn't know how to pull data from databases. So Python, the open sources, looking at where the technology is going, the cloud solutions, and enabling some of the, the SQL and all those things as part of the curriculum would help.
Right. I think thank you very much. I agree very much with that one. So basic is important. So that was a big discussion normally we had among other faculty members when we are at the time of developing our curriculum and revising the curriculums. And I think I'm glad to hear that one. I think there are a couple of faculty members also joining here, and that will become a very good insight when we develop or revise. Right, there are a few more questions. I think we have around maybe 8 to 9 minutes more, but I like to invite the ladies. There is one female student raising hand. I would like to invite Novia. Would you like to ask your question, please?
Thank you. Good morning, Mr. Mani Janikaram. I'm Novia from management industry. This is actually an insight question because I've seen Industry 4.0 firsthand myself, and I have experienced the difficulties of handling management during 4.0. So maybe considering your position, surely your expertise came from experience more than your mastery or something. So when did you take your PhD, and what did the PhD boost your
question, Novia.
skill sets?
That is a great question. I did my, like a master's after coming here in the US, and then immediately I started working. But there are some people who always want to go back to school and learn more. I'm one of them. So I did my PhD time when I was working at Motorola, and actually it took me longer because of the thesis and dissertation. I would not recommend doing PhD part-time, but I ended up doing that anyway. It took me 7 years to complete my PhD. So it was a long process for me. And then of course I went back and did my MBA, executive MBA also. So the reason for, like the way I leverage my process, like I built my bachelor's was mechanical engineering. My master's was industrial systems engineering, but my PhD was more in quality and process control. Because the way I looked at it is I was kind of building, it was a building block for me. And then I did my MBA in international business because I was dealing with international, my team was all over and leadership mattered, right? So running the organization, understanding finance, understanding organizational policies, and international business was critical. So that's why I ended up doing that. And when I put them together, it all kind of, at least for me, it worked well. So I think the short answer is learning never stops. And you don't have to really, like the school and the university provides the best structure for you to learn. But learning can happen from many different ways, particularly in the current mode with the Coursera, with different modes. You can actually, micro masters and things like that. You can learn, many different ways. And I'm actually spending my time, whenever I get some free time, I go and learn some new skills like in the AI. So learning never stops.
So basically school is for the basics of everything that we wanted to learn. It's the logic of thinking that we are learning. Is that right?
It is primarily providing you, problem solving capability, and everything else kind of tops over it.
Yes, very well understood. Very well understood. Thank you.
All right, thank you, Novia, for that question. All right, that's also a great discussion. I think I would like to invite the last one. We have one I think time to answer one more question from Pak Christian Nugroho. I think you are a new doctoral student.
Okay. Thank you, Prof. Nyaman, for the time. Hello, Pak Mani. Can you hear my question?
Hi, good
clearly?
morning. I can hear you.
Okay. In the digital transformation, I think the disruption will never stop, right? It keep happening and will never stop. And Intel is a quite disruptive company for quite long time, but now the competition is limitless, right? So I want to know what your opinion about the competition, especially from Intel. We know that Huawei, right? So they can create literally many things. So they can be your competition from Intel, and also Apple, right? They come from the product industry, but now they create their own chipset, the M1, right? So my question is, how you see it from the Intel perspective, and also about the limitless competition in this industry? That's my question. Thank you.
Great question again. Like you mentioned, Apple M1 chip, and they designed their own chip. I mean, even from the beginning, Apple was designing their own chip, and then they were leveraging for the PC their power, like a series. They were using Intel chips. But from their perspective, Apple is, like don't want to tie down to one supplier, right? They want to diversify, and that's why they always have multi-supplier. And their whole idea is how can they leverage, like various suppliers and keep the cost low. And so I cannot speak for their strategy, but from our perspective, we are a B2B business, business to business. So we want to make sure that our products are leveraged across the industry, like HP, Lenovo, and Dell and others, right? And Apple is still working with us, but their strategy is to go on their own. So I cannot speak for that.
What about the limitless competition that I mean? So now the competition is not only from one industry to another, one company in same industry, right? So different industry can come to be our competitors.
Correct. I think that's also a good question, because there are so many companies. In fact, they say that you can go from sketch to scale, like the Fluxtronics, they now call it as Flux, and Jabil. They are integrators. You can walk to them. You can say, I have an idea that, can you help me? And they can develop it. But end of the day, when you start looking at the top semiconductor companies, there are hardly few. Right? When you look at where do you go for fabrication? You either go to TSMC or Samsung, or you go to Intel, right? And primarily the foundries, there are only few. And then when you want, like an entire solution from design to delivery, and then you're looking at, I don't want to go spend, because it's billions of dollars of investment initially, right, when you design it. But if you take what is available, then it can go to market faster. So that is the kind of big companies can do that. Smaller companies, they have to find different path. And primarily in like high scale, like a PC and cloud computing, there are not many players, right? So that's an area for us to really look at. But IoT is happening the way you were talking about. A lot of people are coming up with their own sensors, but when the data from IoT, it has to go into a cloud. So that means you need cloud solution. Either you go to Azure or you go to AWS. But the servers for cloud comes from only few people like Intel or AMD. So I think it's also a niche market. End of the day, when you start mapping all these things, there are different providers for different things. So that's why we have been profitable, and for the last like several 30+ years. So.
Well, thank you, Professor Mani, Professor Nyaman.
Right. Thank you, Pak Christian. All right. I think I need to give also one question to somebody who is watching you via YouTube, because obviously we have limited capacity here, and many students and other people are watching you from YouTube. There is a question on how to convince management to adopt digitalization, given that probably cost is also an issue. That's the one question. Another one, very last one, is what do you think is the value of a PhD for somebody who is not teaching or doing research at university, but working as a professional? So those are the two questions. Can you address it briefly?
Sure. I'll take the question one, which is how do you convince management of digitization or technology solution, right? The way I look at it is there needs to be a, like a problem looking for a solution. It cannot be a solution looking for a problem. So that means you need to understand what are the big things that the management is trying to solve. What are the big challenges? And then you have to really look at, are these problems that the management is looking at is a candidate for the solution that I am proposing. So that matching has to happen. And then have to look at how other companies have successfully solved it with the technology. Because there is nothing like benchmarking that says, hey, your competition or your peers have been using this technology and they have made big progress. So, and then you have to find what I call as the early adopter. So a person who is willing to work with you, a person who is willing to take the risk. Because when we are doing these things, it's not 100% so we need to find within the management sponsor who is willing to fail fast and learn from it. And so creating that environment, working with them, is how I have been able to take concept to solution. So that is my answer to the first question.
Okay.
And the second question is very interesting. What is the value of PhD? To industry, right? Yeah. Definitely, at least speaking for myself, number one, I wanted to do my PhD no matter what, whether it is in industry, because it was my personal journey. And I benefited by learning process and also benefited by taking what I learned and implementing it into the company. Like, for example, my PhD was in process control. I implemented that to develop various equipment solutions within Intel. And we hire a lot of PhDs because the technology is very complicated. Amazon, for example, hires, primarily they target all the PhDs and then call them as scientists because they know that, they're not paying for all the knowledge that you have gained through your work and PhD, particularly if you do a research that in connection with an industry, mostly even funded by, in fact, I fund a lot of projects where the students, PhD students are working on it. That means they are learning and they're contributing. And when they graduate, they're already ready for hire. So those are the kind of things you have to really look at. And industries are hungry for it, right industries. So today.
Thank you very much. That is a great insight. So there is a big need for industry, for people who hold a PhD, right? Mani, I think the whole lecture, 1 hour and 10 minutes is really great. And I think we all appreciate very much your contribution, especially to new students in our department. And they would start their journey, I think, into now mostly. And I think perhaps we will meet you again sometime in the future. Maybe we would like you to get involved a little bit more probably in our program in the future. Thank you very much.
Be happy to.
Yeah.
Thank you. Good luck to all. Thank you very much.
Thank you very much, and good evening to you.
Thank you very much.
Thank you,
Mr. Mani.
Thank you.
Thank you very much, Dr. Mani.
Thank you.
Thank you for your insight, Mani.
Thank you, my name.
Yeah.
Thank you, Mr.